Welcome to This Explainer. Today, we are diving into a fascinating and, frankly, eye-opening experiment that completely shatters a massive myth about AI and data organization. Look, if you work with data, build directories, or rely on automated pipelines for market insights, you really need to pay attention to this one. We're unpacking the real-world dangers of DIY AI-generated datasets and how they might be quietly sabotaging your analytics right under your nose.
So you've probably heard the hype, right? This constant claim that powerful AI agents can seamlessly search, collate, and organize small data sets with perfect consistency. And I get it, the promise is incredibly tempting. Just feed raw data into an LLM, let it do its magic with web searches, and boom, you've got a perfectly structured pipeline. But let's look past the hype for a second and look at the actual data to see if that claim really holds up.
Well, the answer is zero. Yep, a big fat zero. That is exactly how many companies out of a test group of 10 well-known startups received a perfectly consistent classification across 3 identical AI runs. Zero. Not a single one. Let that sink in for just a second. When asked to simply categorize 10 specific businesses multiple times under the exact same conditions, the AI failed to give a unanimous answer for even one of them. No way, right?
To understand how this complete lack of consistency actually happens, we have to look at the experiment the researchers ran. They took 2 highly capable frontline models, Anthropic's Sonnet 5 and Monis 1.6, and gave them the exact same classification task. And keep in mind, these aren't some clunky legacy models. These are state-of-the-art systems that people trust with complex reasoning every single day.
Okay, so here's the setup. It was a super fair, highly controlled test. The models were given a list of 10 prominent Indian startups, like Acco and BrowserStack, complete with their URLs to avoid any confusion. Web search was fully enabled. The models were then asked to run the identical prompt 3 separate times. The goal? Simply classify each company into a multi-level sector path, like sector to subsector to subsubsector. Identical inputs, identical conditions. 3 consecutive runs. Just look at the sheer chaos that unfolded. Take Anthropic's Sonnet 5, trying to classify BrowserStack. Run 1, it decides the company is developer tools and cloud-based testing. Okay. Run 2, it shifts entirely. Now it's DevOps and software testing. Wait, what? By run 3, it bounces back to developer tools, but totally changes the end of the path to cross-browser app testing. For the exact same company, the model literally couldn't pick a lane. The core concept was kind of there, but the actual hierarchy shifted at every single level. And it gets weirder. Let's look at Acco's results using Manus 1.6. In runs 1 and 2, the model was reasonably consistent, going 3 levels deep and stopping at InsurTech. But then in run 3, it just randomly tacks on a completely unprompted 4th level of granularity, direct-to-consumer insurance. I mean, is Acco an InsurTech company or a D2C insurance company? Both might technically be true in the real world, but in a database, that totally alters your competitive groupings. So the real issue here isn't just about accuracy. It is absolutely crucial that we talk about reliability. For 8 out of the 10 companies tested, every single run produced a completely different classification. That is a disaster if you're building a market map or an investment thesis. A company placed in DevOps 1 minute and developer tools the next means your peer group aggregations are basically just shifting sand. By digging into these bizarre results, the research actually identified 3 distinct patterns of failure that happen when large language models try to organize data on their own. If you want to protect the integrity of your systems, understanding these 3 patterns is a must. Pattern number 1, the taxonomy shuffle. We clearly saw this with BrowserStack. The models just cannot anchor on a single unified taxonomy. They bounce around between standard industry terms and totally made-up descriptive phrases. Now imagine scaling that instability from 10 companies to 1,000 companies. A business tagged as fintech today might be financial services tomorrow. This compounding instability literally turns your downstream insights into absolute noise. Next up is the granularity glitch, perfectly demonstrated by our Acco example. The AI oscillates between broad categories and hyper-narrow categories without any logic at all. And remember, granularity determines exactly what comparisons you can draw. A broad classification groups a company with many peers, a narrow one isolates it. If that fluctuates from run to run, your entire analysis framework just collapses beneath you. But honestly, this third pattern, the false consensus trap, this is arguably the most dangerous trap you can fall into. It's the silent killer of data integrity, and it all comes down to what's happening behind the scenes. Think about it. If you only ran this classification prompt one single time, you'd get a beautifully formatted, confident-looking dataset. You'd think, wow, perfect. It gives you a total false sense of precision. You would never realize that underneath that pristine output, the model is actually just blindly sampling from a wide distribution of possible answers. If you just hit refresh, you get a totally different spreadsheet.
Okay, so how do we escape this trap? How do we actually secure our pipelines? First, you absolutely must lock in a master taxonomy upfront. Give the AI clear, predefined buckets. Don't let it guess. Second, get humans in the loop to validate those outputs. Third, realize that running the AI 10 more times won't fix it. This is a fundamental classification problem. And finally, the most important step, you really need to acquire reliable self-built or third-party datasets.
If you want to build a truly reliable directory, you've got to do it the right way. It starts by defining your own proprietary taxonomy. That strict taxonomy becomes the rock-solid foundation for organizing your data from the ground up. And only when your data is strictly organized can you power accurate discovery, which, at the end of the day, is what drives meaningful deals and business decisions.
So here is the big takeaway from this explainer. Build or buy, but do not rely on AI to generate your core datasets from scratch. You really must use reliable third-party datasets or put in the elbow grease to build structured datasets yourself. The AI simply cannot reliably organize your data pipelines on its own. It's a fantastic tool for a lot of things, but right now, creating stable taxonomies is definitely not one of them.
I'm going to leave you with a thought that's, frankly, a little terrifying. If a state-of-the-art AI model cannot even consistently categorize 10 well-known startups across 3 runs, how much hidden taxonomy chaos is currently polluting your automated data pipelines right this very second? Seriously, you might want to go check on your datasets today.